So I have a few questions, but I encourage everyone in the call to also ask questions. And my first question is really for Valentina. Your presentation is very interesting, and your colleague as well, super interesting. I saw this before, I think, at the AA. There was a presentation at the AA, and I think I saw parts of it, I believe, from Theo. And I just wonder how you use this as an experiment. And you said this is the scope of this research is formulating a hypothesis, is formulating a domain for you to operate within. So how do you think about systems of elegance? Because one thing about your research is that because you're dealing with fluids and sound waves or air waves or vibration. It is just very elegant, it's lots of elegance can be derived from fluid behavior. And I just wonder how you think about systems of elegance when are you working on your research. And we see examples of that in classic books like On Growth and Form, Darcy Thompson's book, or when he's describing fluids and how the physical properties of fluids give shape to life, to things that are alive, and also material properties. And I wonder if you're exploring this at a spatial level, and you are, I can see on the diagrams, but I wonder how you would describe those systems of elegance.
I think I would like also to know Leo's point of view, but for me at least, something very important from this research is that in general, it was all very new, like not coming with this background to the DRL at all. And it was really diving into this world. And I think that the elegance comes also from simplicity. I mean, it has a lot of complex in the behaviors and the wave fields, but we're talking about just force and matter, and with a lot of focus on the energy part, so in the force field, which I think that it's one of the, even if what we're seeing represented is just like this matter, and that's what calls our attention. And of course, because we're architects, we have this, we can be very seduced by how these natural forms take shape so elegantly, as you're saying. But I think that also it added like a new lens where we are actually focusing on something that is not visible to the naked eye, which is all that force field that is behind. And I think the manifestation of that force and being able to engage with that force is what something that, for me, it gave us agency. So the possibility to be able to influence something that is not visible to us, and to try to understand the limitations that we have as humans and when we're engaging with these systems. And I would
Okay.
also like.
Yep.
Yeah, for me, kind of the elegance not only kind of came from the physical aesthetics of it and the kind of shapes it produced, but also kind of the durational processes that really shapes the behavior. And like through this kind of project, kind of gave us kind of a renewed perspective on kind of the world around us, this world that we don't really see. And yeah, like things such as wave interference, when it's visualized and kind of understanding more of the concepts behind it, such as Fourier transform, like these fluid kind of forms, they don't necessarily have to give fluid forms as a result, but through Fourier transform and wave interference, you can actually create kind of any form you want three-dimensionally. So it's kind of like this elegance kind of led to this fascination, a refreshed perspective on this world around us, which is really interesting.
Right, yeah. And did you, so as a sub question, I just wonder if you ever considered the neuroscience of it and the cognition of it, because we know, for example, from some, and that has been presented here in the conference before, and also when I was doing a very brief collaboration with Foster's on the Apple campus, and how people navigate in the Apple campus in the back then called Infinity Loop. We know that our minds, the human brain prefers, for example, caves better than perfectly symmetrical spaces. We process complex environments, especially if they are asymmetrical, much easier than we would process very symmetrical geometry. And this is very well observed in natural navigation, in humans and other animals as well. And I just wonder if you consider that as well, because it brings, so the geometry you generate, even though it's very ephemeral and it's time-based geometry, if you notice, or if you have that feeling that somehow it's just more natural, it's easier to compute as a human navigating space, and therefore this creates cognitive affordance for spaces that reconfigure in time. So it changes over time, but it is still acceptable as a navigation for humans, if that makes sense.
Yeah, I think that what you're suggesting is actually, let's say, something a bit more scientific than something that we were doing a bit more intuitively. And I think that it's very interesting, actually, something that it could have added to the research side. I think that the way that we were seeing the spatial logics is in like two different scales. One, let's say the human scale local influence. And what we were envisioning, it was the possibility to be able to take decisions like with your direct wave field, whatever is right surrounding you. But there is like this overall organizational logic given by the wave interference. And the thing about wave interference is like an infinite interference. So it's going to be all around. And once you start to understand what are the logics of organization, then what we were thinking is like, maybe at the beginning, it's not like having an instruction on how to navigate this space, but the moment that you start to interact and you see that it's responsive, that is how you start to learn how to navigate it, basically coming from the experience and from the participation with the space.
Yeah, because we do have like a fluid, a very good computer fluid dynamics system in our minds, like we do have like a physics system in our minds. We can understand how nature works intuitively, because this is hardwired. Part of it is hardwired, part of it is something we learn along our lives. So I think the patterns you describe, the patterns you describe on the landscapes you create can be potentially a language, for how people can navigate space. Because and it can be quite intuitive, because we observe liquids and we know how they behave. So yeah, I think that is fascinating. I had a second question, but I will, before that second question for you, I'll ask a question to Yuto, if you take questions, Yuto. Yeah. So I'm just very curious about, and it's similar, it's tied to the previous question as well, is on your next steps, I'm curious about how you're going to establish geometry orders as well. How you're going to have this first order voxelized representation, and how you're going to build up on this, because you can add orders as layers of geometry depending on a different rule system you establish. How do you see this happening?
Sorry, what do you mean by geometry order?
Like you could have like a first order geometry, a second order geometry. So for example, if you're creating like a parametric system, geometrical system, you could have that first order geometry, which is the voxel cloud, that you showed. And then on the top of that, you can hang other geometries that are also parametric, and then that voxelized cloud that is being the output of the AI could drive some other geometry. You could derive some more second order geometry from that voxel geometry, or that voxel cloud, which is also geometrical, but we tend not to talk about it as geometry. We talk it as like a point cloud.
Yeah, definitely. Like I think that's definitely possible, and then logical next step. As long as anything is parametric or procedural, I believe like this RL agent can learn the process and then take advantage of it. As a direct sort of like approach, I would say if I were to continue this, I would probably train another agent. So it's going to be like layers or sort of like linear transition of agent, rather than having one agent doing multiple things, or being trained on multiple action steps. But yeah, that's definitely one thing. And I think I mentioned at the end too, but another thing that we can sort of like develop on, which is tangent to this question, is definitely continuous step. So this is like sort of like the voxels or pixels, which is discrete, but there are RL algorithms that can output continuous numbers. So you can sort of like define size, like continuous size or rotations, that kind of things, and then optimize it even better, and then even sort of like in a way pragmatic for real life application. But yeah.
Yeah, no, that's super interesting. And I think you can yield a lot of results because it's very tempting to see your boxes, your collection of voxels, and thinking about having a second order layer that are smaller, so it increases the definition, or just hanging geometries on those voxels. You know, the voxels they define the positioning of vectors or splines or whatever you want to hang on those voxels. But I was not sure if you want to carry on adding definition by creating almost like a fractal-like structure, or if you see it happening as that voxel at that resolution setting a baseline of a possible solution, AI-based solution, and then you hang all the geometries that know what they have to do based on the position of that voxel in space. So that, and then they would generate, I believe, radically different architectures. You know, it can branch into like 2 or 3 very different pathways to generate very novel, very intriguing architecture.
Yeah, definitely.
Yeah. Yeah, just I think just play with that and see what you get. Yeah, so maybe next year we can see. So, and then for Firouzja, so thank you for the presentation. My question there is mainly how you visualize all the integrations, because we saw some images, but so you have your integrated system, right? And how did you visualize this for the different stakeholders, for the designer or for the user or for the system you're putting together? Was this visualized in some particular way, or you come up with data and you show the data?
For the visualization part, we use some softwares. For example, we have used Revit to build the photograph or the image for BMI. And for other parts, like the deep learning models, we had some visualization of our data. So these were all the visualizations that we had. And as far as the framework that we have introduced, we actually when I say we tested it in various ways. We tested it with the outdoor data that we have collected by ourselves, the real world data, and we came up with this framework.
Right. Yeah, that's interesting, because that would be very helpful to communicate the design solution, yeah, or the design option. So just going back to Valentina, so my other question, and it's related to Yuto's question as well, is having that multi-phase liquids. Like, did you try with more than one phase combination, like oil and water, or water and or oil and alcohol, like a very different liquids, so you have like a multi-phase combination, and they will respond differently to the vibrations. Is this something you've considered?
So for the bouncing droplet phenomenon itself, we were very restricted to this material, this particular silicone oil, because of its viscosity, which is very specific, and just to be able to visualize these organizations. But there was a consideration of actually a different material, a non-Newtonian material, when we were trying to speculate on scaling it up. First of all, when we did this bigger prototype, we had to do a switch to water, and we did few tests with agave, just like to try to change the viscosity of water, to try to get to something closer to the bouncing droplets, which is 20 CST. So just as a reference, let's say water is between like almost 0. This is 20. Honey is like 3,000 viscosity. So we did envision a material like cornstarch, because we were kind of fascinated with this idea that maybe of this material that can be fluid, but also give some solidity when impacted. So let's say that academia's schedule weren't enough for our research, so we ran out of time to be able to do this test, but like it's something that we've considered to really try.
Yeah, because you do get some fascinating effects. So you can have cracks and fluid behavior together, you know. So it can be fluid and can be crumbling, and non-Newtonian fluids, they can come up with a very interesting shapes because it's somehow more constructive. There are lots of videos in the internet of people putting cornstarch mix with water on subwoofer speakers, and then the whole thing grows up and looks like lots of little guys dancing and things like that. So
Yes.
that's quite interesting. But I was thinking like a multi-phase, as in, for example, you have like a 2 layers, right? Oil and water.
Mm.
And then you have the space of the depth to play with, because they would compose literally the interface of them would compose a different space from the surface space. And that is also very interesting. And then you have things like a ferrofluid as well that would behave in a very, very different way. So, and that could be yet another, because ferrofluid is basically an oil with is very small iron particles in it, like the suspension, right? So that would be also part of the multi-phase combination, but yet in a different way, because it could respond to magnetism. So you could create some very exquisite, really, really exquisite sonic, what I would like to call sonic gardens, you know?
Mm.
This is sonic landscape architecture type of thing. So that's quite interesting. I know people say, oh, but this is not computational, strictly speaking. But first of all, it could be computational, as you just described. There's a different culture in that sense of run computational design experiments. But it also can evocate imagery that we don't see in reality, and that can change the way we produce computational design. So I think it's super interesting. And I also think it's super interesting to, like, a Yuto's presentation is just remarkable, and it's quite distinct in the sense that and I know his research well, is just how articulated it is to set up a foundation for a tool that can also can evocate those images that normally you don't see in reality so often in the reality of the computational design practice. We are still in the industry, with a few exceptions out there, like some people at Foster's, Zaha, and some people at Gary, that we are in that reality that we use a very kind of a limited palette for the production of constructible architecture, constructible design. And there are so many other things out there we could be using. There is also, and I don't know for all of you presenting today in this session, there is the articulation of novel ways to think about architecture solutions. So usually we are very bad, even the best architects in the world, we are all very bad at coming up with a solution in the real world of practice, come up with solutions that actually stick. We see lots of architects, doesn't matter how famous or not famous or how big or how small they are. We're all very, very good at coming up with architecture that once it's appropriated by the owner or user, it's completely reconfigured and recoded because the intended program for that architecture just did not stick. So it has been designed from a very idealistic point of view, and people go and build it. And then when people go to live in that space or they go to use that space, they literally move things around, they close windows and open windows elsewhere, or they demolish a wall because in the reality of inhabiting that space, that idealized concept did not stick. It did not translate to something that is accepted by the user. And I think, kind of this kind of investigations of very different angles can help us to see a better solution for the final architecture, for the final outcome. And I just wonder what you have to say about that, if this is the reason, because you might come back to me and say, no, but I don't care. I just do that because I think it's really cool or it's really beautiful. Yeah, I don't care about the final building, but I just wonder if you have something to say about that. I starting, yeah.
Yeah. All right.
Yeah.
For me, like at least very clear perspective that I have on this after our project is actually because like conventional architecture is conceived as fixed and finite. And our whole thesis, even if it's put into an extreme of saying like the full space is going to be reconfiguring based on the participation of the human, it made us think this variable that Leo mentioned, the variable of time, which is not like just the passage and like, no, it's really an architecture that evolves over time and like being able to identify those changes. So just the fact of considering the architecture as an evolution over time challenge you to reconsider how you're going to be conceiving in it. I think that for us it was kind of the key thing in our, and I think what you're saying is kind of, let's say, the thing I were trying to provoke. An opposition to that, like considering architecture just as static, because then it fails. Like even if it's in the most banal thing of just like saying we move things around, I think that is one of the invitation of the research.
Yes, yeah, so it is indeed. And very few architects think about that. I know so many architects that they design and then they make the client happy and the build is built, the building is built, and then they walk away. They never look back pretty much. They just walk away and go to the next project. And 10 years later, down the line, they say, oh, that building that I designed was demolished or was changed or doesn't that happen? And they never really stop to think why that has happened. So what I find fascinating about the presentations today is that so the time you're dealing with the fluids, it's a very fast time, right?
Yeah.
So did you try to create any relationship between this very fast time and the very long time scales of the built environment? I did an experiment like that when I was doing my master's at the Bartlett. But I tried to run that experiment that they've done in Tokyo to work out the best connections between metro stations. Yeah, so you establish centroids and then you create a maze and you put some mode there and you let it find its best route possible. And it does. But this is because we're dealing with structural architecture. The structure, it's the physical object. You're not dealing with the structure of time. That is okay. But I just wonder if you try to do this with your experiment, if you would, if at that time it's scalable for urban time. I don't think there is right or wrong answer. I think we can just talk about it, but I just wonder what you think about it.
I think for the timescale in the physical experiments, we kind of always saw it as a physical constraint and kind of took it for granted. And it was actually quite interesting when we tried to simulate it. The simulations actually kind of non-dimensionalized the time, and it was kind of scaled the time to an extent where you can actually see the droplets bounce one bounce at a time. And that kind of non-dimensionalization of time, it kind of gave us this perspective that this computational tool could actually act, like instrumentalize a really fast phenomenon like the bouncing droplet into something that's more architecturally related for the built environment.
Yeah, because you might be able to draw lines there. If you're looking at the ontology of time, how time is described as a field of knowledge, there I think something like 20 or so different types of time. So if you look into that, you might find, okay, this can be translatable into a much larger scale. And then I think this is something that we architects often miss. Yeah, we don't like to think about time very much. Some people do think about time. So you see this in some Thai architecture, but in a kind of Thai palaces and so on. It's all about the navigation, and that navigation can be spoiled if you go too fast or too slow. So there is those notions. So there are some really fascinating concepts out there. And Yuto, what would be your thoughts in terms of not time, but thinking about those kind of you mentioned on your last slide, scaling up and so forth, but this translations, this set of
Yeah. But definitely, like working in practice, I definitely feel sort of limitations in introducing new tools, or even like applying some, researches that we think improves the design and therefore like build industry. I think one huge thing, I mean, kind of you sort of mentioned a bit, but like it is a client thing, and then we're always sort of like employed by the client, and then a lot of decisions are made by the client. But at the same time, I think we can't just use that as an excuse, and then tend to, like a lot of architects or like architectural offices tend to be passive about that and can't really or don't really want to fight against it. I mean, it is also a collective effort too, I think, as architects, as a collection, or even like designers, or even, consultants in this industry should probably push more towards utilization of contemporary digital tools, and then these like really cool things that we've been doing and then basically available. So yeah, I think that's definitely what we need right now, especially in this sort of like time and age where it's like more flexible, fluid, rapid. Yeah, it is definitely necessary.
Yes, yeah, absolutely. I think, and it's as a designer, as designers, it's our job. I think it's part of the job description to get streams of value like that. Like this value that we can sense and feel because we have that sensibility, and make it evident to the client, and not only the client, because the client is usually the guy paying for the building or the urban development, but to the user, to the end user or users, the communities that will be using what has been designed. And then there are like some pretty amazing examples that value is very self-evident. So at the moment, I'm working on the knowledge management of the next 2 nuclear power stations in the UK. And when you design a nuclear power station, you also need to think about the nuclear waste, and you're going to put that stuff somewhere, and it needs to be there for 10,000 years. 10,000 years is not 10 days, it's 10,000 years. So that cannot leak or crack or break. You need to design it because the perceived value by the end user and the client, it's very self-evident. We need to design something that is good enough to last for a huge amount of time. That is, we can say it, I can say it in 1,000 years, but for me, as a human being, it's very hard to realize what 10,000 years entails, and then when we talk about housing, it's very interesting, the financial model for housing, especially for contractors, because lots of very big contractors, they don't want to work on housing, building housing, because for them it's not profitable enough. They
Mhm.
don't care because they want to make a quick profit, and then they think, oh, we're going to design something, and then in 20 years, because that perceived value is not there, in 20 years they'll probably demolish, or whatever we build is going to last 20 years, 50 years, or whatever, and then after it's going to be demolished. But is it? Because you go to certain places, like you go to some towns in Switzerland or some places like Paris, for example, and then they have buildings there that are a good 300, 400, 500 years old, and they look fantastic. So why do we need to treat housing as something that is like an artifact that you throw away after 20, 50 years? Maybe it shouldn't be like that because, first of all, it's not really sustainable. Yeah, so we need to think about that. And that kind of those notions of time and the notion of value streams on the design we produce sometimes is not evident to the client and to the user. And I think techniques like that, and also kind of integrative frameworks like we've seen today, helps to make that evident. And we need to, I think we need to make this more visible. Because if people, what they say, if you don't see it, you don't believe it, so people need to see things to believe. And this is particularly problematic now that you can generate whatever you want with AI. But if you have a solid methodology behind what you're showing, that has a lot more weight. So I think, yeah, I'm just very grateful for the wonderful presentations. I wonder if somebody in the audience if anyone has any final questions, if you have any questions, and if not, I think we can call the day.